everybody. Thanks so much for joining us for today's episode of the TypeAlias Show live stream. Today we're going to take a look at Arrow to see how easy it is to get started with it, even if, like me, you're not a functional programming developer. And to talk through Arrow, we've even got a super secret surprise guest joining us today. I'm excited. We'll catch up on some of the latest news in the Kotlin and Android worlds, of course. We're also going to look at some fascinating ideas for value types that are buried deep in the recesses of the Keep repository. We're going to look at some of your responses to some of my earlier videos and a lot more. So with me today behind the scenes, as always, is my lovely producer, who also happens to be my wife, Elizabeth. Round of applause for the producer. All right, we have up in chat, make sure you fill out the poll. Let us know how familiar you are with Arrow, and that way we can sort of fine-tune our discussion today as needed. And speaking of chat, it really is my favorite part of doing these live streams. So everybody say hello in the chat and let me know what is the current outdoor temperature where you're tuning in from. I want to know because here in Nashville, Tennessee in the US, we've had a much colder winter than we're used to. In fact, one night we even got down to around like 6 degrees Fahrenheit, which is like negative 14 Celsius, I think. But it wasn't all bad. As you can see, we had some fun times walking through the snow. We usually only get snow a couple times a year, and this time it actually got up to about 4 inches. So that was a lot of fun to walk through that and see our dog Ninja running around through it and having fun with it. But I think we're actually reaching some warmer temperatures today. I think we're getting up to the 60s even. So like that's Fahrenheit. So that's what, 16 or 17 Celsius maybe. So again, say hi in chat. We're excited that you're here. And let us know how cold you are, or maybe you're in the southern hemisphere, and maybe you're actually quite warm. I don't know. Next, I wanted to take just a minute to thank everyone for your support of the channel because we recently hit some big milestones. We got 10,000 subscribers and 250,000 views. So, wow, that is great. We're so happy about that. My producer and I just love what we're doing here. We're so thankful for just such a great, encouraging community, and well, we're going to keep at it. So again, thank you all for making that happen, and we look forward to lots more great things coming up this year. So normally we jump into the news section first, but like I said before, we've got a super duper secret surprise guest joining us today. So we're going to dive right into Arrow. And so everybody get your confetti emoji reactions ready down there in the chat where you got the little confetti button you can hit. And welcome to the show, our very first live stream guest, all the way from JetBrains. It's Kotlin language developer and Arrow contributor, Alejandro Serrano Mena. All right. Welcome to the show. Big secret surprise. That's right. Well, we're so glad you're here. I'm thrilled to have you on the show today. And I know you're really busy working on Kotlin language features, including pattern guards, which we looked at last time in the show. I think you're working on that. But today we're focusing on Arrow. And so to start off with, I think we would love to hear about your experience as a contributor to the Arrow project. So how long have you been contributing to Arrow, and what kinds of contributions have you focused on?
Yeah, so I started contributing about 2 years ago. So I used to do mostly functional programming on like more typical pure functional languages like Haskell and Scala before that. And then I joined a company back then called 47 Degrees, and they actually had some people already working on that. So most of the other maintainers like Raul, Simon, Paco, they come from there. We've met there. And I don't know, that looked like I was learning Kotlin because I wanted to like move from from this kind of languages to maybe something which I could essentially get more work done, and that was like a perfect fit for me. So in these 2 years, I started contributing a bit, and then at some point, I actually got involved into like more new features we were trying to develop. Maybe if somebody has been following the history of Arrow, we did something called Arrow Analysis, which was trying to get some extra compiler plugins and so on. And then we've also revamped how all the type errors in the library worked internally, so I was involved in that. And yeah, since, let's say, a few months, it's a bit calmer. We pushed to get the 2.0 release, not very, I think, right before Christmas, and then now it's kind of calm. Like mostly what I do now is maintenance with the rest of maintainers. So getting the bugs fixed and usually figuring out complicated scenarios where like KSP is failing because it's running from Maven, and then we don't know what's happening. Yeah.
Yeah, that's great. I didn't realize that you had been at 47 Degrees, and that's kind of the name. It's like the company name that I associate with Arrow the most, just because I know like a lot of those guys have been big contributors to Arrow for years now. Yeah, that's great. Well, Arrow has got sort of a reputation as the predominant Kotlin library for developers who are into functional programming. And you mentioned a little bit about Haskell and Scala, I think. Yeah, tell us a little bit more about just FP, your FP experience in general, even in languages prior to Kotlin.
As I said, I started my career also. Well, I originally started working on academia, and then I moved slowly to industry. And I said I started mostly working with Haskell, and that's kind of a pure functional programming where this kind of language where you really have a very different mindset if you want to dive into that, because well you have to do things differently. So I was also in the weird situation where I actually had to go the opposite direction. So I was very used to many of these functional programming idioms, and I then transitioned to Scala and then to Kotlin and all of that. And yeah, like if you want to do things in a pure functional way, you have like I see like two different kinds of things. So there is a thing which is like how you model all your data, and many of that things like using these data classes, using a lot of like what in Kotlin would be sealed classes. This is very translatable to Kotlin, for example. So I that's the kind of thing I try to get. And then there is all the other, what I think most people associate with functional programming, like things like monads and all of that. And that's a lot have to do with the fact that because this is this kind of functional programming is more pure, there sometimes you need to do a bit of bending if you want to like finally get to the database to access it. And that's actually the kind of things that I don't think are needed in Kotlin. Like if you try to write functional programming in Kotlin, what we mostly mean is the other part, how you model your data, how to ensure that everything doesn't have side effects, and it's kind of a more general thing. So that's kind of how I ended up doing Arrow. Arrow is kind of what it's even if you try to do this Arrow, Kotlin was still missing a few pieces, and Arrow is what tries to like get the 3-4 pieces that for somebody who does functional programming are missing in the language. Well, you can just put them in a library and then you import them. Then you are like, well, I can use the language I want with the kind of mental model I want to be in control.
Yeah, that's great. I know with just the very, very small amount of Haskell that I've done, that it was very different experience because when you have guarantees that this data structure is entirely immutable, there's no way that it's going to possibly change. I'm not making an assumption. I'm not saying that by convention we're doing it this way. It's like it's basically baked into the language that you're going to do things a certain way. And again, I don't have a lot of experience with it, but that was kind of my big takeaway. I think developers who maybe aren't into FP, the Kotlin developers who aren't into FP, they might feel a little intimidated about the idea of pulling in some massive FP library just to maybe introduce a handful of features that they'd be interested in. So tell me a little bit about like the structure of Arrow overall, and like how much commitment do you have to make even just in order to get started with it?
I mean, in theory, you can even look at the Arrow library as a set of, it's actually a set of libraries. So we like to call it the kind of the Arrow project, where what we like to see is that each small library kind of complements a part of the Kotlin standard library or ecosystem. So essentially what we have is something called arrow core, and that kind of complements the standard library, which a few types. One is either, which is like result, and one is non-empty list, which is like a list which is not empty. I mean that there is nothing more to that. But these are like this small thing that you are missing if you're coming from a functional programming background. Then we have other library called FX, which kind of complements coroutines. So it's like a using the coroutines library, but in a more high level fashion, how you would be doing this if you use more high level library things like parallelism. And then we have maybe what is a bit more convoluted is the optics library. That's things that you are missing when you try to go full or 90% immutable. Then Kotlin has this weird thing where you need to start calling copy inside of the copy, and it becomes difficult. So optic is a solution inspired by how you would do it in functional programming to this problem. There are many solutions. This is a solution we brought from that. And then we have other libraries that essentially start complementing other parts. So we recently got something that complements compose. I don't know. So we try to make this very small things. So if you are in a library already, then you bring the complement and nothing else. You don't need to buy into the whole thing. You can buy it if you want. I mean, it's like you can get your 17 libraries in one by importing the arrow stack library. But
Is it actually 17?
I think the last time I counted, yes, because every serialization library also is in a different module. So you can you have the Jackson and the JSON and the serialization. So those are already 3. So yeah, I think the last time I counted was like 17 with all the compatibility modules.
Yeah. Okay. So 17 different smaller, kind of bite-sized, as it were, libraries that can be pulled in one-off or together. And I guess, are they all versioned together? Is that how that works? Or do you need a bill of materials when you're pulling in a bunch of things at once? Or
right now it's a bit complicated because like this started in different repositories. We're trying to actually migrate everything to like a, let's say, Arrow mono repository. But now you have like everything is 2.0.1 as of today, except one called suspend app, which is like something about how you can handle finalization for the whole library if you need to handle this, especially on server side, and that has a different theme, but we are trying to pull it in. And the integration modules also used to live like in 4 different repos. We are trying to make our life not a pain, so every time we need like do 4 different CI pipelines. But yeah, mostly everything is 2.0.1 in one go. Yeah.
Okay. Yeah, that is great. And I think one of the big things I've noticed here is that this is actually maybe surprisingly for some people very applicable to Android development. I think it's probably you and I were talking beforehand about how it's been adopted a lot on backend, but really it's got a lot of great goodies in there for front-end development.
I have to say that was when I moved to Kotlin, one of my surprises. I mentioned I used to do Haskell, but also Elm, which is like a front-end library in that. And well, I used to learn how that works. And then I thought, well, okay, now I'm doing Kotlin. I need to learn, all the Android thing, which is very different, like the and then suddenly somebody shows me composing. This is the same like I was doing in Elm. So it's like functional in a sense, right? Everything is very decoupled, and then you have like one point which your mutable state where you update, and that's essentially how the functional programming frameworks work with other words, but that's essentially the same idea.
Yeah.
So yes, great. I don't need to learn new ideas, right? I can just change a few words, and then I know compose, of course.
Yeah, but you get at least kind of the main ideas behind it. That's really cool, and I think that we have kind of seen a lot of that happening where it's a little more. I think some of the front end stuff is starting to come together. I mean, even with Swift UI is obviously very different in the way that it structures things. Where you've got more objects and things, but I kind of feel like there's been a little bit more of a push toward, especially the the single direction cycle, unidirectional flow of data and everything. And we'll look at that here in just a minute too. But yeah, I'm kind of happy to see that there's kind of a convergence, I guess, in some ways of some of these ideas, which is really cool. So I don't have much experience with Arrow myself. I just wanted to clarify that for you and for all the folks who are watching. But we did open a poll, like I mentioned before, to ask everybody in chat about their experience with Arrow. So let's take a look at the poll results here. And it looks like we've got, roughly 20%, a little shy, 17% there who have used it in some capacity. But in large part, we've got an audience who's going to be brand new to it. So I feel like I'm in good company now, that I'm not the only one who hasn't had much experience with it. So I'm hoping that by the end of this segment here, that everybody will have a good idea of what it's like to work with Arrow and what benefits they can get, even if FP sounds like an intimidating thing to them. So I am excited to get into some code here. So I put together a simple desktop, composed desktop project, and this is going to demonstrate some of Arrow's features. So let me see if we can pull up the screen and cameras here. There we go. And this is just a very simple list of wrestlers, and you might have seen these wrestlers from the coroutines chapter that I wrote in the illustrated guide. And so that's kind of where they come from, or the coroutines presentation that I did. Some of you have seen that as well. And this is just a very simple app. We got just 3 wrestlers, and you can come in, and if you want to change his name from Sledge to Sludge, we can save that. There's no way to add a new wrestler. It's just getting the list, editing an individual one, and that's about it. And by the way, I do want to say that if anybody wants to follow along with the code for today, you can do that. We've got the source code up on GitHub. Whoops, sorry about that. Popped it up too soon there. I'll let my producer run things. That's what happens when I run it on my own. GitHub.com, TypeAlias Studios live stream with our with this month on it, and you'll be able to follow along. We've got a couple of tags in there for that project that show each step along the way that we're going to be doing. So feel free to take a look at that and follow along, or afterward, if you have questions, you'll be able to take a look at that. And it's also linked, I believe, in the description box on YouTube here. Okay, so now that you've got the main idea of what this is doing, I want to give you just a quick look at the view models and the repositories. The source code online also has the front end part of it, the composed piece of it, but mainly the stuff that I'm looking at here today is going to be focused on the view models and the repository. So let's take a quick look at what we've got here. This is going to feel very familiar to you if you are if you're familiar with the kind of the Google's recommendations for architecture for front-end applications. This is going to feel pretty familiar. Like, there's not much different here. We've got the UI state here for this list. We've got these different statuses. I kind of like to do this where when you first load the screen, you're coming in with no data, and then it switches to a state where it's loading that data, and then when it's loaded, we can take that spinner off and show you the data. Or if there's an error, we can do that as well. The main code for the wrestler list view model here has this exactly as you would expect. We've got a single UI state object, and that is going to have this as state flow that is going to be public, and the immutable part of it's going to be private. This class here only has the refresh, so you can only fetch the data for the list, and that's all we need to do here. This is going to update the state to tell the front end that it's loading, and then we're just going to call the wrestler's repository. And I'm going to show you a little bit about the server side here in a minute too, because I structured this in a particular way for a reason, and I'll explain that in a minute. Once the data are loaded, we just update the front end to tell it that it's loaded, and we send along the wrestler data. Not too different on the edit view model. This has got the data class for the edit screen. We've got the statuses that you can have for that screen, and then the actual view model itself again. We've got the UI state. All of this is very, very normal for Compose apps. We've got a function to load a single ID, so a single wrestler. It's going to, again, tell the front end that it's loading it. It's going to load it from the repository, and then it's going to update the front end to tell it that it's loaded and send that along. So very similar pattern. This is not unusual. Saving is going to be roughly the same thing here. You see we've got the set the state to begin with, do the work, and then update the front end with the result. Things get a little bit more interesting down here with the set name, set age, set weight, set city. These are all for the individual fields on that form, so that when you're typing in the box, it's going to store that information in the view model here, and it's going to create copies of the data class that we're using for the UI state here. Back behind that, we've got the repository. Very simple. This is just using KTOR client to make a call to a server. And we've got one request to get the wrestler IDs. We've got another request to get an individual wrestler, and then to save a wrestler, we use a put. We're obviously going to switch that over to the IO dispatcher. So very, very simple, very common structure for that. This is shared. Let's go to server real quick, and I want to show you what I'm doing here. This is just using a KTOR server. We have an endpoint for getting the wrestlers, and this is going to give you just the list of IDs for the wrestlers. Like I said, I'm doing that for a very particular reason. Take a look at that in a minute. This is get wrestlers by ID, so you're getting a single wrestler. So if you want any of the data, even if you just want the wrestler's name, you've got to get the list for the ID and then send that ID to this endpoint. And then to save one, or update, I should say, we've got this put endpoint. And then some static resources for that. You can see down here we've got the data are just being saved in memory. So we're not storing it to a database. We're not storing it on a file anywhere. This is just in memory. All right, so what I wanted to do was I wanted to show this side by side with some updates that I made to use Arrow. And Alejandro, I'm going to show you some code, and you might laugh. And if you do, it's okay. Like if I'm doing things in a way that's not very Arrow, I totally want to hear about it, and we can get a good laugh out of it. So let me put this in, let's actually put this here. That'll be a little bit more room. So on the left-hand side, we've got the main code. So this is just what we're starting with. On the right-hand side here, I believe this is, make sure this has got the code that I'm looking for. And we're starting with we're actually starting with the repository. Let's go there. Okay, so I'm really excited about this. One of the big things that I discovered in Arrow's library is the resilience feature. And I gotta say, I was really impressed with this one. So when we're building multi-tiered applications, there's always the risk that one of our requests isn't gonna succeed. And I have to admit that on a lot of the projects I've worked on in the past, there really wasn't an adequate amount of work put into things like properly retrying failed requests. I think it ends up just kind of being an afterthought. So ideas like exponential backoff make a lot of sense to us, but having to code all that logic by hand is kind of intimidating. But Arrow actually made this really easy. I was really excited about this. So let's take a look at the wrestler repository here, and let me pull up wrestler repository on the left so you can kind of see the difference and how it really didn't add very much in terms of like, there wasn't much that I had to add, much code to make this thing happen. But let's look at these lines right here. We've got the policy that I created, and I'm just telling it I want an exponential backoff retry policy, and I set it to 250 milliseconds, and to do that until as long as 15 seconds. So in other words, what I'm telling Arrow here is to try to make this request, and if it fails, then wait 250 milliseconds and try again. If it fails that time, we'll wait another 500 milliseconds. And if that fails, we'll wait 1 second and so on. And then it just kind of does that up until 15 seconds, at which point it kind of throws up its hands and says, well, I guess I can't do anything about this. So I also have the code down here. Once we set up the policy, all I had to do was wrap my calls in policy.retry. And I did that on all three of these here. And that was really all it took, just the one member variable up here. And honestly, we probably would even move this into the constructor parameter so that callers or dependency injection could configure it. So Alejandro, tell me what you think about this feature and the way that I used it here. Is this kind of on par with what you expected?
I mean, that's how it's supposed to be used. Like the resilience library, it's like our attempt of making it easy to do this, because as you say, if you try to essentially implement this, well, everybody ends up implementing like their own variable, and you have to track a lot of different stuff. So yeah, that's how it's actually supposed to be. You want to like here, actually the only kind of functional programming idea, if you want to call it, is what makes it simple to do is because you are separating kind of the definition of the schedule, the definition of the policy, from the actual execution of the policy. This idea, which is very typical in like the functional programming circles, of you don't do stuff, you say what you want to do, and then you do it in separate things, actually helps a lot in these kind of things. And so this is how you should use the schedule. There is actually, in the resilience library, you can go even a step farther by using something called a circuit breaker, which essentially allows you to say, well, if you have failed too many times, please don't overload the server by trying more. And you often this is actually done in such a way that you can share the same circuit breaker between different calls. So even if your calls are in parallel, they all take into account the same circuit breaker, which means that, it's not that one thread is blocked. Is that, well, if one thread already detects that that server is overloaded, all of them are going to stop, and all of them are going to come back whenever it's detected that it can go far. So that's just, well, if you want to use the circuit breaker, you essentially add the same thing of a policy, and then you do the circuit breaker dot protect, and then again all of these runs. What I often do is I end up having like a function which just calls the policy retry circuit breaker dot protect, and then I wrap everything with the same thing, and then, well, all your thing is protected quite easily.
That is really impressive that all of this is just so lightweight in the code. Like, there's a lot behind it, but it's very easy to use, very lightweight. Do you want to talk to me about Saga? Just kind of quick introduction of what that is.
Yeah, so Saga is yet another of these resilience patterns where, well, this essentially takes into the idea that sometimes you need to talk to different servers, right? And you want to perform something which is atomic in nature, but you cannot have the atomicity warranties of like a database, because you need to do it in calling three different services, let's say, right? So what you want to do is, if the third one fails, you actually want to roll back the second and the first, actually in that inverse order, to get everything back to where it was, so that you know that if you have completed the operation, everything is consistent. And Saga is one of these patterns, and here is an implementation where essentially for every operation, you say how you invert the operation. So if your operation is incrementing, your inverse is decrementing. So if you, for every operation, say this, the Saga constructor actually what will do is they will try to do this, and as I said, if at some point something breaks, it will roll back everything. So it's again, it's not something which I think conceptually it's complicated. The implementation is quite tricky, because everything which has to do with coroutines in Kotlin has potentially exceptions and cancellations and all of that. So this has the seal of approval of Simon Verhoeven, which is our coroutine expert in Arrow, which I fully trust on his code. So that's it. It's just another typical pattern for resilience, which we implemented here.
Yeah, that is fantastic. So lots of great resilience features in the resilience library in Arrow. So I was really thrilled with just how easy that was. So good job to the Arrow team on that one. That's fantastic. Let's see the next thing that I worked on, which was parallel map. And so I mentioned before that I structured the service in such a way that if you wanted to get the list of wrestlers, you just get the IDs back. And if you wanted any information, just the name even, you'd have to call one off to get each one of them. That is definitely not how we would want to structure our service. But there are lots of times where you're using some third-party service and they just structure it in such a way where you can't get all the data that you want in one shot, and you kind of have to piece it together from different places. So that's why I did it that way here. So let's pull up the list VM on this side as well, so we can see just what that looked like. So this is the main code on the left. This is where we started with wrestlers getting wrestler IDs. And then I did a map and I launched a new coroutine using async to fetch the data for each wrestler and awaited all of them and then loaded them in that way. And Arrow has some features to make coroutines a little bit easier to use. Here I used something called a parallel map. And you can see I've got really just, I didn't have to do a separate async here or the await all. And all I had to do is parallel map, and it was able to fetch those wrestler IDs, and then for each one of them, fetch the wrestler, and it's doing this in parallel. So I just want to point out that this is not like one at a time. All three of these requests are, at least as far as I know, all three of these requests are happening at one time, assuming that we've got a thread pool that's big enough to handle that or whatever. So Alejandro, tell me about this one. Did I set this up right, and is this a good use of it, or is there other things I'm missing here?
That's the idea. So a lot of the FX library, which is the name we give to the coroutine kind of companion, is about kind of showing a more high level structure to your code. So coroutines give us awesome things, async, await, and all of that, but sometimes you want to just kind of say a bit more what you want to do, right? I want to map, and I want my map to occur in parallel. I don't want to like having to create my list of defers and then await. It's just, this tiny thing, which here it's just 2 lines, but when you start composing more stuff, it just blows up. So yeah, that's how you want to use bar map. It actually takes even some extra arguments, so you can say, well, please don't try to do everything in parallel. Even if you have like 10 million threads, you can say, well, just do as a block of maximum 5 things at the same time. So you can even control some of that, which that part is actually hard to do if you really want to use it with async and await. All of this is quite hard. And we also have the kind of the similar called parsip, and that's where you don't want to do the same thing in parallel, but you want to do several things in parallel. And again, a lot of the complexity there is if you want to do this with async, you often end up having to say, well, what happens if the first one is canceled? If the first one throws an exception, I need to cancel the second one. And some of them is taken care of by the coroutines itself, but some is not completely done because, again, it's exposed as a more low-level thing. And parsip does the same idea of just bringing this more high level to all of this. So when I write code, essentially I just put a bunch of parsip and parmap and almost never use async and await until
Wow.
it's super small because, well, yeah.
Yeah, I get what you're saying here because the mindset of being more, like you hear a lot with functional programming that you're focused more on being declarative rather than imperative, and that does kind of come out here. And sometimes, like you said, the syntax difference, it might not be a huge syntax difference, but the mindset of just declaring what you want is really nice and kind of tucking away that imperative part into something that's more declarative. So that's really cool. I'm glad. So hey, so far I'm 2 for 2 here. I did all right. It sounds like you're saying I'm doing all right with Arrow. So that's good to know. I'm on the right track here.
I have to be honest here. It's also very nice that Kotlin already has things like map. So if you start from when I teach this to like people with maybe a more Java backgrounds, which they all know map right now, right? But there's a lot of people which it's not the first things they use, but in Kotlin people just use map, so it's like, well, just put the par on front from parallel, and then you have a parallel map. I don't know. There is nothing more to explain.
Yeah.